Hi, it is now chapter reviews. Through chapter review, we'll consider definitions, strategies, and try to solve some examples. Okay, the first chapter is functions. The angle can be defined with the unit circle. Let's see the circle of radius 1. If you draw a line segment from the origin to the circle, then you can find an angle. Once the arc length is theta, then we define the angle theta. So the arc length is 2 pi for the whole circle, so that whole circulation is 2 pi. So here the angle is theta when the corresponding arc length is theta. In this way, we can define angle. Now here, sine theta, cosine theta are here for the point. The vertical component is sine theta for the angle theta, and horizontal component is cosine theta. And of course, that arc length is a theta. And now tangent theta is here in, you can use this formula, sine, once we are using x notation, then tangent x is sine x over cosine x. But once this bottom length is 1, then that is tangent theta. Okay, so here in this figure, now sine theta, and theta is larger than equal to sine theta, and that's also bounded by now tangent theta, right? Okay, so anyway here for the point, x horizontal component is cosine theta, and vertical component is sine theta, and tangent theta is the same as sine theta over cosine theta, and now that is slope. Okay, also very frequently used trigonometric formula is sine squared plus cosine squared is 1 for every angle. Okay. Example 6.1, identify the amplitude and the period for the function and sketch its graph. Okay, the amplitude is absolute value of this portion, so that amplitude is 2. For period, okay, now x over 2 is moving from 0 to 2 pi, then here the cosine will make a whole circulation, so that, and pi over 2 changes 2 pi, then whole circulation. That means that here x itself is changing from 0 to 4 pi. By multiplying 2, you can reach that here, that is the period. Okay, so period is 4 pi. And now when you try to make a sketch, okay, here, an x coordinate and y coordinate, there's x direction, there's y direction. Okay, this itself is the values between -2 to 2, and now +1 means that the range must be -1 to 3. Okay, so that you may try to get here now 3, and here -1 is here, so that the function graph must be inside here. Okay, now we already know that is 4 pi, and for example, at a point the value is known, then you can finish the whole graph. For example, right now, once x equals 0, when x equals 0, then, okay, x equals 0, then y must be here minus 2 cosine pi and plus 1. Cosine pi is now minus 1, and so that is here 2 plus 1, so that is 3. Okay, here is 1, the value 3, and now after 4 pi, it should be again the value, but it is so center is now 1 here, so, and that is a 4 pi, and 2 pi is go down the bottom, so that it's going down here and then up here and reach at this point. Okay, for the left side, right side is continuously now here you can expand the same way continuously outside. Okay, and also of course this side. Okay, now find all possible values of a for the following equation to admit a unique solution theta in 0 and pi. Okay, first of all, you can solve the problem geometrically. Okay, now that one, and here that is sine squared theta. Okay, that means that between 0 and pi, and sine squared theta is given in this way. And then cosine theta is here, once a is 1, then anyway start with here, and cosine theta itself is here the value is 1, and at pi the value is minus 1. Along with a, it can be scaled. Once a is positive, then start with a, and here end with minus a, so that they are continuous, so that always it has a unique solution. Once a is positive and a is negative, then start with here a, and now over there minus a. So again, it has a unique solution. So geometrically, a is non-zero, then it is unique solution. If a is 0, then sine squared theta equals 0 has two solutions here and here, right? So geometrically, you can find a is non-zero. But for this problem, the basic technique for solving the trigonometric equation involving sine and cosine, then you have to unify either into sine or cosine by using the trigonometric formula, and sine squared plus cosine squared is 1. Here from this one, sine squared is same as 1 minus cosine squared. So by using that, here the sine squared is 1 minus cosine squared theta equal a cosine theta. Now we can here change into the change variable x equal cosine theta. Theta is between 0 and pi, so that x must be value from minus 1 to 1. Okay. Now, along with the variable, can be written in this way. That is x squared and plus a x, and now there is minus 1 equal 0. Okay. We have to find a so that it has unique solution. Okay. Here, once a is 0, also the same here now. Okay, it is passing that point, -1. And now once a is negative, then the solution must be between -1 to 1. Once a is 0, then here's a 2 solution. But once a is negative, then that means that here you can easily see that now, in fact, a is positive, then it is moving that direction, so that that is changing in this way. So that here the y-intercept is now less than -1. Also, you can see quite easily here that happen. In fact, for that equation, no matter what a is, here, if it has 2 solutions, then now alpha beta, then alpha times beta must be -1. You learned this one from high school. That means that here, once one solution is less than 1 in modulus, in absolute value is less than 1, the other one must be larger than 1. And they should have opposite sign so that it makes -1. So here, once it's less than 1, then it's larger than 1 in modulus, so that, and it has a unique solution. Only possibility having 2 solutions is that, and alpha and beta are now of magnitude 1. One is 1 and the other one is -1. So in the case, it has 2 solutions except that, and every other case here, only the unique solution will appear. Okay, so from that one, and here, if a is now non-zero, then one of them must be, for example, alpha must be less than 1. So that's the solution. And beta in modulus, okay. Okay, one of them modulus must be larger than 1, so that it is only one solution. So unique solution is guaranteed. Okay. Section 1.6, inverse functions and logarithms. Inverse function is defined once in this way. Once f is 1 to 1, then inverse of the function is now defined in this way. For example, and here f of xy, and if we define f inverse of y equal x, then that is the same as here now fx equal y. So when you try to find the inverse function, then first you start with y equal fx, and here solve for x and interchange x and y. That is how you can get inverse function. And for example, here fx is x cubed minus 2, like this one. Then you start with y equal x cubed minus 2 and solve for x. Then first we move this into the other side and third power is applied. So we reach that one. We solve for x and interchange and x and y. So that finally we have that the right side is inverse of f. That is now this red curve. So because of this interchange, and here now inverse, the graph of the inverse function is a reflection of the original graph with respect to y equal x. Okay, for exponential functions, y equal a to the x. Now we have to solve for x if we want to find inverse of that. Now, but it's not along with here addition, subtraction, multiplication, and division, so that by using standard way we cannot solve it. So now we introduce some new notation such that if we solve the problem, solve for x, then we write down that one into this way: log ax, x equal log base a and x. That is basically the result of solving for x. Okay, the last one is not x, I'm sorry. Yeah, that is here now y. Okay, and then from this one, xy will be interchanged, then y equal log base a and x. So that is inverse of the exponential function. So once you see this logarithmic function, then you may consider that equation basically log ax equal y is the same as this equation a to the y equal x. Okay, so here the one thing you have to remember is that now for exponential function, the logarithm is inverse. Okay, now we have the logarithmic rules, product rule. Once product inside for the logarithm, then you can separate along with addition. Once it's quotient, then along with subtraction, and power can go in front of the logarithm. And reciprocal rule, this is a special case. 1 over x is the same as x to the minus 1, so that minus 1 can go out by using the power rule. And when you try to manipulate expression, then you may use that identity, a to the x. Now, that one, okay, a to the x is the same as e to the logarithm, natural logarithm of, okay, here, and that a to the x. So here, now, e and natural logarithm is a logarithm with base e, so that e to the logarithm, they are inverse each other, and it is like identity. So a to the x is a to the x. Now, by using power rule, here x can go in front of a logarithm, which is that term. So you can use this identity when you try to manipulate expression along with exponential functions. Okay, now here for any a positive, of course not 1, and logarithm ax can be written in this way. Now here natural logarithm of x divided by natural logarithm of a. So that is the change of base formula. So that when you are using the computer, usually for you can see arbitrary logarithm with arbitrary base. However, when you are using computer or calculator, only possible the logarithm is basically here now natural logarithm or log base 10. In computer, usually that is now used along with log, and that is a log 10. Okay. Okay. Now here, we will try to solve for x. Okay, these are already we did from earlier when we try to solve the lecture note problems, but among them now we try to solve this problem only here now. Okay, for that one, by using product rule, left hand side can be changed in this way. That is a log base of 3 and x minus 2. And right side, there's 1. That is now same as log and 3 and 3. Base and the input are the same, then the result is 1. Now we can eliminate here log 3, so that from this one we can reach here x minus 2 equal 3, and we can rewrite this one x squared minus 2x minus 3 equal 0, and 1 3 separation plus 1 minus 1, so that we have here x equal minus 1 and 3. Okay. However, now logarithm is accepting only positive values, so that x must be positive, x must be larger than 2, which implies that only the solution is now x equal 3. Okay. For here, inverse the sign. So arc sine is inverse over sine. So sine is inverse. If you can cancel out once it is inside of the domain, but a sine function itself is oscillatory, so that now once it's not one-to-one, but once we restrict the domain between here, between 0 to pi, 0 to, no. That is minus pi over 2 to pi over 2. Then it is an inclusion function and one-to-one, so that its inverse can be defined. So now here this angle is between here that area, then of course you can cancel out, but this is out of the domain when the sine is used as considered as one-to-one function. But here this value is the same as basically now sine and pi over 4, 2 pi, and can be cancelled out, so that sine pi over 4. Now pi over 4 is inside of that one, so that you can cancel now sine and arc sine, so that eventually now this right side must be pi over 4. If you write down this one, then it's wrong. That's wrong. And of course, now this quantity is the same as pi over 4. Okay. Now arc cosine, cosine are inverse each other, but arc cosine is accepting value between -1 and 1, and so that here is not defined, so that you cannot cancel here cosine, arc cosine. Okay, so this whole thing is not defined, but this left hand side, that one is if 9 pi over 4 is not given, then your answer must be pi over 4. Okay. Use a geometric manipulation to simplify the expression sine tangent inverse over x. Okay, here let's start with this one, tangent inverse, which is arctangent x. Let's say that is theta. then it's the same as now x equal tangent theta. So you can visualize in this way. There's a right triangle, and now angle is a theta. Once you choose this as 1, then must be x, so that tangent theta is same as now x. Okay. Now, once it is a theta, then the question is, what is a sine theta? So that the question is changing into this form. So if you evaluate the sine theta, then that's the answer. Now, by using Pythagorean theorem, we can see that hypotenuse, length of the hypotenuse is 1 plus x squared. So that here we have the given term is the same as sine theta. That whole thing is the same as sine theta, which is now x over square root of 1 plus x squared. That is the final answer. Okay, that is the end of chapter 1. Thank you.